My name is Vandana Techie, and I'm a second year undergraduate student at University of California, Santa Cruz. And I will be conducting this interview today. Humans in Neuroscience is a Simply Neuroscience outreach initiative dedicated to sharing the stories of humans in neuroscience and psychology of all ages and educational backgrounds to showcase amazing diversity in the field. On behalf of the entire HON team, I'm pleased to welcome Dr. Sandra Pearl and Dr. Elizabeth Bless. So tell us a little bit about yourself,
So my name is Sandra Pearl, and I have a PhD in neuroscience. In my non-neuroscience life, I am the mother of 5 kids. They are all in high school or college or beyond by now. I love to do outdoor stuff. So I also teach kayaking and stand-up paddleboard and lead hikes and love biking. I do a lot of outdoor activities. And together with my partner, we have founded a nonprofit organization. We use the shortened acronym of SEED, Science and Engineering Education Development. And our goal is to reach out and improve science in the really young ages, like the elementary ages. Liz?
My name is Dr. Liz Bless, and I also was a former laboratory neuroscientist and have been in many capacities through academia and biotech, and as of more recently with Dr. Pearl or Sandy, have been running this nonprofit organization, SEED. I absolutely love animals. That's my big thing. I've had so many different pets, and oftentimes the kids, when we go into the classrooms, ask us about, because we do a lot of dissections when we go into the classrooms, and they ask, do we like animals? And I adore animals. I've had hamsters and rats and mice and guinea pigs and dogs and cats all as pets. So that's my passion. I also have 2 children. I love them as well.
Thank you. So what caused you to begin such amazing nonprofit organization? I read about SEED online. I was wondering, what motivated you to create this organization and bring forth this program to a lot of high school students?
Liz and I worked for an organization where we went into a lot of elementary schools, and we would kind of do a fun science experiment and then we would leave. And what we learned is that those young elementary age students receive very little science in their day. At those young ages, it's really focused on reading and math, and the students aren't receiving a lot of science. Also, their teachers, although their teachers are energetic and love science, they don't particularly feel confident teaching science to those young ages because their own background was more in education, of course, and not directly in science. So Liz and I saw a real need to both help the students learn more science, experience more hands-on science, but then also to try to give the teachers more confidence so that they might teach more science to their students as well.
I would just add on to that I think that we both, because we've been laboratory scientists, we understand the characteristics that are necessary to become good scientists. And those are characteristics that are not necessarily taught or prioritized in the younger ages. So for example, we are very insistent that the students make predictions and feel very comfortable being wrong in their predictions, and that scientists are expected to be wrong, but that it's more about thinking and it's less about trying to memorize or know all of the facts. So the critical thinking and the curiosity is what we really like to foster.
I know in your previous research, you have done a lot about neuroscience and pharmacy and different aspects of research in your previous, not currently now, but previously. So what drew you to neuroscience specifically?
I think I originally was thinking that I would go into clinical psychology, and I spent an intensive 6-week program in undergraduate education at an inpatient ward in Bangor, Maine. And the patients really fascinated me. They were very sick patients, schizophrenic patients mostly. And I became very interested about what is going on in the brain and how this is affecting their behavior and the biological aspects of this all happening. At the time, I was also reading the book, The Man Who Mistook His Wife for a Hat by Oliver Sacks, and I was absolutely fascinated by every story in this book. It gave me shivers just reading all of the things that the brain can do.
I actually was a chemistry major in college. And so I started to think a little bit about there being chemicals in the brain. And that's how I got into neuroscience. I should add, though, that when Liz and I were undergrads, there really was no undergrad study of neuroscience then. Now, of course, there is, but at the time, we didn't have the opportunity to learn about that as undergrads. So we kind of jumped right into grad school, hoping that was a topic we enjoyed just based on how much we had that tiny bit of exposure to in either our own reading or a little bit in courses.
Tell us about your brain journey. Like, can you tell me about yourself and your work in neuroscience specifically?
I guess my interest really did evolve through undergrad. I went to Colby College for my undergraduate education. And as I said, I was thinking I wanted to go into clinical psychology. I then, after school, spent 2 years at Mass General Hospital in a depression research clinic, where we looked at a lot of addenda studies. Back then Prozac was fairly new, so we were interested in how long you had to stay on Prozac for it to be effective. That really led me to more of a biological bent, and finally thinking I don't necessarily want to work with patients, but I really want to know more about the brain. And ended up doing a master's at Northeastern, a PhD at Boston College. I then did an academic postdoc that was a 5-year postdoc, during which time I had my children. And after that, I tried out biotech, and I worked on some drug development for stroke at a company called Curis. And so then after that, I started staying home for a while with my kids. They both had some health issues. And I found outlets for my interest in science. So I was doing some things with the kids at schools and that sort of thing. Ultimately, I did want to go back to the lab. I wrote a re-entry grant, and this is something that not a lot of students know about. If you go into the sciences and then you decide that you're going to stop being in the lab for a number of years, there are resources to get you back into the laboratory. So this was specifically a grant that you can write for funding so that you can fund your own research after you've been out for a little while, take care of family or whatever you're doing in your life. So I did that at Wellesley College, and eventually sort of got more interested in this early education. That's where I am now.
Mine is maybe a little more direct than Liz. So right from undergraduate, I went to graduate school at Albany Medical College. Immediately when I graduated and had my PhD from there, I did my postdoc. My graduate work had been in new medications to treat drug addiction, one of which is still ongoing a little bit. It's a psychotropic drug that has shown some efficacy in treating long-term drug addicts. When I went to do my postdoc research, I switched fields and began to study Parkinson's disease. And although those two topics sound completely disparate, they actually share a lot of the same pathways in the brain. So there is quite a lot of commonality between those two. When I was finished with my postdoc, it was right when I was having all my kids. So I also took some time to just kind of be with my little kids at that time, but always in the background, I was using my science. So always I was teaching of one kind or another. So I taught at several small colleges. I would teach for a whole semester covering somebody's maternity leave. So I was always teaching science, not perfectly neuroscience, but always teaching science along the way. I also went into my kids' classroom. I would bring in little experiments with rockets, or I would show them how to do some fun activity or another, that the teachers were so grateful to have a real scientist come in and just kind of bring something really fun and hands-on that they didn't feel comfortable doing themselves. Eventually, after all the years of teaching, I met Liz, where we were both teaching really young ages, which was a little bit new to both of us, but because we had had kids and been in our own classrooms, it didn't feel completely different. And it's so fun to work with young kids. Their imaginations are wide open. You can talk about any science topic you want, and they'll have questions about it. So Liz and I are always thrilled to answer their questions, which are, why does having a bigger brain mean you're smarter? Or is it true that this animal is smarter than this animal? Or is my dog colorblind? You know, we really just love all the questions they have, often of which are related to neuroscience eventually.
I'd say 50% of the questions, we don't know the answers, which is really fun because I always tell the kids that in all the years that I've been in meetings with other PhD scientists, I've never thought about some of the questions that we get from these kindergarten through 6th grade kids. They ask questions that are really interesting and unique. So that's always exciting for us.
That's really sweet. You guys offer such programs for kids in elementary school, because I think also, like, as I went to elementary school, our science was so vague. Like, it was just a textbook, right? So you don't really go into different aspects and topics of neuroscience. That's amazing, actually. What parts of the brains do the kids like to enjoy learning about?
We do a couple really fun things with them. So I'll tell one, and then I'm sure Liz can share another. We have been doing a little experiment where we teach them about learning, how your brain can learn, and how adaptable your brain is to learning in a different way. So you may have done this in your own kind of fun, but we have them throw a beanbag at a target. Then they put on goggles that shift their vision, and they have to throw the beanbag again. And of course, at first they miss the beanbag, but through their own neuroplasticity and learning, their brain adjusts and they start to hit the beanbag even when they're wearing these weird goggles. Then they take their goggles off, and now their brain at first tries to keep throwing it where it used to, but then readapts. So we have a lot of fun little activities like that that really show them, like, your brain literally just learned something and changed back and learned again. And look how adaptable that is. That's one that we really love to do with the students. Liz, and you can name them 10 more.
Oh yeah, well we do. You know, it's funny now that I'm thinking about a lot of, I guess because we're both in neuroscience, we sort of bend some of the things that each grade has its own standards. So one of the things that we do is physical waves, but we put a big bend on it. We do a lot with sensation and perception. So we have some lessons on vision and how we see color, and the kids are always fascinated. Like Sandy said, we sort of show them, this is what dogs see, but this is what we see. We show them that if you actually mix different colors of light, you get white. Not, you know, we ask them, what would happen if you mix red and green and yellow? And they say, oh, you get like a brown color. And we give them flashlights that are different colors. And when they actually shine them together, oh, it's white. And then they're really like fascinated on how we perceive these things. I feel like we also get a lot of questions about sleep and subconscious brain and that sort of thing. Yeah.
And then of course we literally bring brains in. So we can show them mouse brains versus sheep brains. And we try to get them to think, like, look at the mouse brain. It's really smooth. It doesn't have any, well, we call them wrinkles. It doesn't have any wrinkles. What do you think it means that this sheep brain does? And they often figure it out that those wrinkles that we call them are related to higher level thinking. Mm-hmm. So there is nothing about the brain that they don't love learning. They love learning how big their own brain is. Was Albert Einstein's brain bigger than my brain? What makes someone smarter than someone else? They love it. And Liz and I, of course, keep playing on and could talk all day about that.
Yeah. So during your process, like, did you face any like issues regarding like stereotypes in terms of your work or ignorance or anything when you were trying to pursue certain things in your research work?
There's a lot about women in science, and we do a lot about women in science. Like we have specific programs that are sort of centered on learning more about women in science and their research, and maybe you haven't heard of this woman that actually was the one who discovered DNA, not Watson and Crick. So we do a lot with that. But in my personal education and along the way in my career, I feel like being a woman in science has not been a hindrance to me at all. I feel that I've been treated equally and without any sort of reservation by the people that I've worked with.
I feel super lucky to have had such supportive people along the way. In really the majority of my chemistry faculty as an undergrad were women, and they were super supportive of all of us pursuing even a higher degree. And then in grad school, although my department was dominated by men, I never made to feel that I was valued less than any of the other students there. So I hope, Liz, and my experience isn't unique. I hope that people feel supported throughout all of their schooling and education.
I think it's really changed in the last maybe 20 years. Things have really changed in the sciences for women specifically.
So how do you guys feel about your current place in neuroscience?
I think that neither of us are right now pursuing lab or neuroscience per se careers. But I think, like we've been saying, we definitely bring neuroscience into the classrooms. We both feel that it's sort of an overarching topic that can certainly be relatable for really any standard that we're trying to cover for any grade. So I think that although I started my career very centered on neuroscience, and obviously when you go to graduate school you're doing something so tiny and specific in neuroscience, and now it's much broader, but really exciting to be able to relate everything that I've learned throughout my education and my career and be able to take it into another realm.
I know you guys mentioned seed a lot. So how are you guys feeling about your place in seed and what do you feel is your biggest accomplishment for seed?
I feel like there was a whole lot of room for elementary science to change and grow. And I love that Liz and I are helping to be a part of that. There is so much more we can do to bring more science to our young students, and they love science. It is such a hands-on, engaged, fun topic to study at school. So it's a little bit of a challenge to help teachers figure out how to incorporate that into all the other things that they need to do. But science can be integrated into so many other fields that they're already working on in school. With a slight twist, you're now doing science as opposed to maybe math or maybe even history. Twist that a little bit and you can learn about how something came to be, which is really the scientific process in most cases. I'm really excited that every time we meet with a teacher, every time we meet with a student, we are giving them one little edge closer to feeling like a scientist themselves. And that's really exciting.
Sandy and I work in a lot of districts that have less resources. So we are able to bring more equity to the students by providing all the materials that they need, because that is something in the elementary schools that they're really lacking. They just don't have the finances to get materials to do science. So through grants, through both local banks and cultural councils and a whole bunch of different organizations, we've been able to provide the supplies and the materials that so the students can really, like Sandy said, feel like scientists. They have their hands on the materials they're doing instead of just reading or watching. And it's been really important for us to make sure that all students have access to these materials.
What do you think the field of neuroscience needs more of in today's age, like kids need more of?
Kids and schools need more access, more funding to help support added science programs at their school. And I would say if that can't be made to fit into the normal school day, then let's give them after school opportunities or out of school opportunities. So funding of the sciences and of supplies and of materials and of teacher training in the younger school grades is very important and should be a high priority as soon as we can make it one.
I think your initiative and your goals for this organization and the work that you guys have done is amazing. I think it's so needed in today's age because there's so many kids who sometimes don't have the opportunity to obviously go into these neuroscience or any aspect of science, as a lot of times you have to be one of those smartest kids to get into those like really good schools that provide all the interesting science aspects that aren't provided in the general public schools. So I think your initiative is great that you guys are doing this, and it's amazing to see how kids are so active and really interested. And I really hope that this interview can get to more kids and see what work you guys have been doing through this time, and maybe we can reach more students, more elementary school teachers and other students, high school students as well, to pursue a field of science that interests them. So thank you so much for your valuable time, and we're looking forward to
Thank you.
seeing what happens.
Thank you for speaking with us and bringing more attention to young people in science as they move forward and become college age and beyond. So thank you
Thank you.
for speaking with us today.